Hello friends, welcome to online school. And then in this video, let's talk about differentiation of functions by product and quotient rules. But then let's begin with product rule. So here we have that given a function y equal to uv, where u and v are functions of x, then the derivative of y with respect to x is given by dy dx equal to v du dx plus u dv dx. And then so this is what we refer to as product rule. So you happen to note that generally we have a function u, which is a function of x, and then v is also a function of x. So we have these two functions, two sets of functions multiplying each other to form a product. So whenever you get two sets of functions multiplying each other, you can differentiate them using product rule. If at all that you form a product, then this product can be differentiated using product rule. And then so product rule in general is like you keep one set of function, which is v in this case, and then you differentiate the other function, which is to get du dx, and then you add, keeping one other function, and then you differentiate the other set of function with respect to x. So now let's first try to see how to derive product rule, and then later on we shall see how to use it. So here we have our function y equal to uv. Let's begin from this y equal to uv, and then so this function here y equal to uv, we are going to derive product rule from this step here using first principles like the previous tutorial. And then so I want to just let's first begin with this. So let's begin by adding small changes. So we shall say that y plus change in y equal to u plus change in u, close brackets, and v plus change in v. Then by so doing, I've added small changes to each of these variables here. Then after that, we know that we subtract the two equations, and then we shall have y plus change in y minus y being equal to, so we can simplify. Well, let's first leave it as it is. So we shall have u plus change in u. Then we shall also have v plus change in v minus uv. And then by so doing, we've subtracted this from this equation here. So we shall have this one here. It will simplify to change in y being equal to u plus change in u. Then we also have v plus change in v minus uv, right? And then when we reach there, we can simplify these or open these brackets, and then so we shall get to change in y equal to uv. This time was this, then plus u time was change in v to get u change in v, then plus v time was change in u to get v change in u, then plus change in u times change in v, we get change in u, change in v. Alright, like that. Then we also have minus uv here. So note that this uv will cross out with this uv, or will cancel out with this uv, and then we shall remain with change in y equal to u change in v plus v change in u plus change in u change in v. And then so after simplifying that, we know that from first principles we can divide through by the change in x. So we shall have this side of change in y divided by change in x, and then even this other side, the whole of this, being divided through by the change in x. So at this point here, we can take the limits, but then we know that the limit or dy dx is given by the limit of change in y over change in x. So now here we shall have, as change in x approaches 0, even these other changes, which is change in v, will also approach 0. Even the change in u will approach 0. But then you happen to find that this is a product of two changes, and then if at all we have change in u approaching 0 being multiplied by a change in v approaching 0, so almost this term here, it will just completely get to 0. So but then we have these other parts here. We can even say that dy dx will equal to the limit as change in x approaches 0 of change in y over change in x. So this time here, when we get change in x approaching 0, it will just get to dy dx, and then we can simplify even this other part here. So we shall have the other term, which is u change in v over change in x, also approaching, or it will get to u dv dx, as change in x approaches 0. This change in x here approaching 0. So we shall have change in v also approaching 0 to get dv dx. And then also lastly, we shall have v change in u over change in x. This time here it will get to v du dx. Alright, like that. And then so lastly we can get to our product rule, which is dy dx equal to u dv dx plus v du dx. And then so remember that this last term here it will be in this format. So for this last term here we shall have change in u change in v over change in x approaching 0, because now this is a product of two small changes. And then so when these changes they are getting smaller and smaller, we shall have the whole term reducing to 0 and then remain with this as our product rule. So this is what we call our product rule, and by so doing you have derived the product rule. And then so in the next video let's look at how to use product rule.